This graph here, often known as a Rose curve, it's of the form r equals a cosine of n theta, where n is an integer. When we have this, it's called a Rose curve because it has a certain number of petals. If n is odd, then it has n petals. If n is even, we actually double it, and it has 2n petals. And then a is the length of a petal. So let's go ahead and put this all together for this. N is 3, so it's odd, so we have 3 petals. We have 3 petals, and they have a length of 2. Okay. Now, what we're going to do, so we've got we'll set up our axes here. What we need to know is the location of these petals. And essentially, we need to know when is r the biggest. Okay, so we set, that would be, of course, when cosine is equal to 1. Okay, or, of course, negative 1. But we just need to find a place where it's 1. That would be when 3 theta equals 0. So theta equals 0. So we have a petal at theta equals 0, so coming out this way. Okay, then we just need to space them out evenly. So we have the full revolution of 2 pi, and we divide that by the number of petals. So here that's dividing by 3 petals. Okay, and I'm not going to put an n, I'm going to put a number there, because if n is even, then it's actually 2n. So 2 pi over 3 is how we move to get to the next petal. And so from 0 to 2 pi over 3, that's right there. And then we move another 2 pi over 3. And another 2 pi over 3 would put us at 4 pi over 3. That's down here. Okay, so these are the locations of the petals. And now it's just a kind of a rough sketch. And what we do is we have it comes out and then wraps around like that. And actually what happens is it wraps around, and it's very, well, something like that. And these are what they look like. Let me give you the calculator. Let me show you kind of how that works. So I'll type this in just so you can see. So we have 2, and then we have cosine of 3 theta. And so I can graph that. And so you can see that it wraps around like that. And of course it comes out to 2 there. And so this, comes out, it's the length of the petal, so it comes out to 2. That's out at a length of 2. And that's out at a length of 2.